Hello everyone, my name is Kotapati Venkatramani and this presentation is for SIT706 Cloud Computing Project. This project focuses on implementing a highly available WordPress infrastructure using Amazon Web Services and designing an enterprise-level cloud-native e-commerce architecture. So in this project, I implemented several AWS services, including Virtual Private Cloud, EC2, Amazon RDS, Application Load Balancer, Autoscaling Group, Amazon S3, and AWS CloudFormation. So the main objective of this project was to design and deploy a scalable and fault-tolerant cloud environment using AWS services. Then the deployed infrastructure was designed to improve high availability, resiliency, security, and operational efficiency. So the project was divided into two phases, in which phase one involved the practical implementation of a highly available WordPress infrastructure on AWS, and phase two focused on proposing a modern enterprise e-commerce architecture using serverless, and managed AWS services. So for practical implementation, I first created a custom VPC using the IP range 192.168.0.0/16. Here I'll show you this one. So after that, I created four subnets. This is the four subnets I created across two different availability zones. Two public subnets were used for internet-facing services, such as the application load balancer and NAT gateway, and two private subnets were used for backend services and database deployment. After that, an internet gateway was attached to the VPC. Here, yeah, this one. The internet gateway was attached to the VPC to provide internet access for public resources. And after that, a NAT gateway was then deployed inside a public subnet to allow instances located in private subnets to access software updates securely without exposing them directly to the internet. So after that, a separate route tables were configured. This one's I configured separate route tables for public and private subnet traffic management. So, and after that, the security groups were configured following the least privilege access principles. These are the security groups which I created. And after that, the application load balancer accepted HTTP traffic from the internet. Then the EC2 instances accepted traffic only from the load balancer. And the RDS database accepted MySQL traffic only from the EC2 web servers. And MySQL Amazon RDS database was deployed inside private subnets. Here I'll show you RDS deployment. This is I did RDS deployment. So to improve database redundancy and availability, a RED replica was also created in a separate availability zone. So an EC2 instance using Amazon Linux 2 was launched and configured using EC2 user data script. And about Apache, PHP, MySQL client utilities, and WordPress were installed automatically during the provisioning process. And the WordPress application and then connected successfully to the Amazon RDS database. This is the WordPress connected. And after that, I did login and everything. So after deployment of the WordPress was accessed through this browser and configured successfully. So to improve scalability and fault tolerance, an application load balancer was deployed across multiple public subnets. And the load balancer disturbed incoming traffic between backend EC2 instance. A launch template and auto-scaling groups were created using EC2 AMI image. This is the auto-scaling and AMI image. These are the AMI image and load balancer deployment. This is the auto-scaling group I did. Then uploaded media files were automatically stored inside S3 bucket to improve scalability, storage, durability, and content availability. And after that, AWS CloudFormation templates are also created to support infrastructure as code deployment practices. The cloud Automation improves automation deployment consistency and infrastructure management efficiency. So coming to the phase, second phase, this is the second phase, which is a business scenarios. Uh, this second phase of the project focused on designing a proposed enterprise cloud native e-commerce architecture. Here users access the application through Amazon Route 53 and Amazon CloudFront. AWS WF is used to protect the application from malicious traffic and web-based attacks. The front-end application is hosted using Amazon S3 static website hosting. API requests are processed through the Amazon API Gateway. AWS Lambda and Amazon ECS Fargate are used for backend application processing. Amazon DynamoDB is used as a primary NoSQL database because of its scalability and low latency performance. And then the Amazon Elastic Cache Ready is used for the session management and caching. CloudWatch provides monitoring and logging services across the infrastructure. So AWS KMS and Secrets Manager improves security by encrypting data and securely managing credentials and application secrets. And the architecture also includes, so I'll show you architecture here. This is the architecture diagram. So this architecture also includes a multi-region disaster recovery using DynamoDB global tables, S3 cross-region replication, and Route 53 failover routing. And the enterprise architecture was designed to satisfy business requirements related to scalability, security, low latency, and disaster recovery. AWS Lambda and DynamoDB provide automatic scalability with minimal administration overhead. And the CloudFront improves global application performance by caching content closer to users through edge location. Here, AWS WF, KMS, and Secret Manager improve infrastructure security and encryption management. And the architecture satisfies the required recovery point objective of 15 minutes and recovery time objective of 1 hour. So in conclusion, this project successfully demonstrated the deployment of a highly available WordPress infrastructure using AWS cloud services. So the implementation incorporated networking, compute, database, load balancing, auto scaling, and storage services to improve scalability and fault tolerance. So this the proposed enterprise architecture also demonstrated how serverless and managed AWS services can support globally scalable e-commerce platforms with improved security and disaster recovery capabilities. Thank you.